Hello everyone, this is Avinash Kumar Singh and I am going to tell you today about a project that you can implement it on for your final year and for your master's project as well. It will be implemented on Xilinx platform and coding will be done in Verilog. So this is the basic 8-point DIT-50 algorithm as you can see it, and this is my input. This is the input and this is the basic structure that needed to be implemented to get the output of DIT 50 unit. So this is the basic butterfly unit 4.50 and then 8.50 and you will get this like that. Okay, so in the mathematical expression, as you have studied in the Xilinx system how to calculate DFT, discrete Fourier transform, for some quantized values, and this is the basic total factor is there. Implementing this one 0 point, this total factor is very difficult. This total factor, because 0.707 representation in binary you will get a floating point type of thing, and it's not easy to do it. So I have taken a very precise approach and very good approach to deal with it as well. So I will teach you today how to do it, and let's see. So this algorithm, as I have said you, that implemented on Xilinx platform. So come to my desktop where I have a project navigator that is actually going, and that is a virtual box is there, and that project navigator of Xilinx is going to be opened in Linux platform using VirtualBox. So if you are not able to install it, I can help you on that prospect as well. So let's see, let's open my project and we'll tell you how it is going to be done. Let's go VirtualBox to get opened. This is getting opening in virtual machine in Linux platform, right? So it may take some time. Wait a second now. So this project is all about converting that quantized value into the frequency domain using DFT algorithm. We are using butterfly structure and 4.8.50 structure to convert it, and so many papers are there on IEEE for that as well. So my approach is very different because I am taking the quantized value, and twiddle factor, that is 0.707, is also deal very efficiently, and you will check it out that my output is 100% correct. So all these things is covered very well, and I will let you know. Okay, so actually Xilinx, if you go to the site and download it, downloading it is also a very big task. So it will take time. When you will not able to download it, please comment me. Please give me message on my mail ID. I will send you the whole code. Right. So okay. So, here I am. So let's open the project. Open project, that is already I have implemented it. That is 8 point, and I am using cogstone adder for the project and multiplier as well. So many multiplier, and I have taken 32-bit. All of them is 32-bit. So this is the basic code. Okay. So this is the test bench. Actually, I have implemented it. In the test bench, you can see that we have real part and imaginary part. I have taken imaginary part 0 and real part as 1, 2, 4, 8, 16, 8, 32 and 8 bit is there. 8-bit quantized. I've taken more bigger values because it will give you clear idea about that there is a precise calculation in that project. So this is the top module, and so let's see what is going to be happen. We are going to simulate it, and then we check the syntax that if any error is there. No, there is no error in the test bench. In the top module, if you want to check if any error is there, there is no error in the top module as well. So in the test bench, we will simulate it. So we are simulating the output for that particular inputs. As these are all binary, so we will select all and change the radix into the signed decimal. Here it is. This is the signed decimal thing, right? So here you can see that output 1 here is real and imaginary part. Output 2 real and imaginary part. This is like that, right? And this is the output. Okay. So when you come to this structure, as you can see that we have 255, then 480.48.3, imaginary part is 166, then for the 2 case minus 51 102, this is the real part and this is the imaginary part, right? So this, as you can see that this is the imaginary part, and this is the real part, and this is one is the imaginary part. And when you come to the calculation case, here you can see this is the calculated like that only. For the 0 case we have 255. For the x1 case we are getting something like that, minus 30 and plus j120 and like that. X2 case we are getting minus 51 j102. So one take only x2. X2 is minus 51 and 102, right? In my output it will become on x3 because it is taken from 0. So here you see, output is minus 51 102. Here you can see real part and imaginary part. It is coming exactly what is required. First one is 255, right? First one is 255. First one is 255, right? First one is 255. Here you can see 255. So my output is here also 255. Second one is 48 166, right? 48 166. Fourth one is 20. Let's see, x is minus 51 and x is 102. So it is going to be minus 51 and 102. Okay, so this is the very correct output, and there is no issue in the output at all. So we want to save change. So git application. Yes, we are doing git application. So top module is implemented. Let's implement it using uh, design summary is also there. As you can say that number of slices, availability, these are the output that you can mention in your project and compare with the other existing project as well. I have at the end I want to tell you that for that project you have to mail me on the email address that is given below in the video link, and I will tell you give you the project, and there may be some charges or something like that, but we can negotiate on that case. And I am here to help you installing the Xilinx software and on your PC. If any doubt is there, I will be here to help you on that regard as well. Any question arises, you can mail me. I will answer it. And this is very good project. You can implement it. You can further implement 32.50 as well by using this project. Okay, thank you.